In this problem, we are given 3 graphs, and we are asked to find which one is the function, which one the derivative, and which one the second derivative. The easiest way to do one problem like this is to look for interesting features of the graphs. Okay, it's the only way. So in this case, it's very obvious when we look at the graphs that there are some points where these functions have horizontal tangents. For example, the red graph has a horizontal tangent at x equals 0, and also the blue one. Those two have a 0 slope. So if one of these functions has to represent a derivative, a slope, then it has to be the green one, okay? Because the green one has crosses, it has a root, crosses the axis at x equals 0. So that means a 0 derivative. So the green could be the derivative of either A or B. So we need to figure out which is which. But we know already that this graph C is going to be the derivative of one of the other two. Now, there is another quite prominent feature here, that is when we look at the graph B, it has 2 zeros, 2 points where it crosses the axis. And if we look at the other graphs, we realize that graph C has horizontal tangents at those points. So that gives us the information that we were missing. What do we deduce from here? It looks like graph A is going to be the graph of the function, okay? And then the slope is going to be 0. So we have a 0 root, okay, for graph C, which should be the derivative. Okay, and that graph C has 2 points with a horizontal slope that translates into a 0 of its derivative. So then the graph B, the blue one, corresponds to the derivative of the derivative. So it's f second. And like this, we are able to figure out which is which.